Recording has started.
Welcome to the final presentation for CS7641 uh, by Team 18. So our project is about image segmentation. Next. So image segmentation aims at dividing an image into meaningful parts. It serves as an intermediate steps for more complicated tasks. So based on its importance and close connection to machine learning algorithms, we chose image segmentation as a topic of our project. So we have used both unsupervised and supervised methods to solve the problem. Next. So we used k-means library provided by sklearn to achieve semantic segmentation. So we picked k values from 2 to 15, which is the ideal k range for images in the testing set. So to find the best values for k, we have used both elbow method and the silhouette coefficients and plot their curves. Then we realized that the silhouette coefficient is better at indicating the best k values, thus used it to determine the final segmentation result. Next. So those are the sample outputs of k-means algorithms. We can see that the silhouette coefficient is better at indicating which k we should pick. Next. So we have used the dbScan library provided by sklearn to achieve semantic segmentation. So we segmented each image according to both pixel values and coordinate values, or just pixel values only. So for the parameters, we have manually adjusted their values, then visually inspect and evaluate the output image until we have found the best parameter combination. Next is a comparison between different approaches. And next is a comparison between different parameter combinations. So for the sample output, we have used used epsilon equals to 5 and minimum sample size equals to 8 as the final output. Next.
For segmentation using GMM, we use GMM provided by sklearn. We segmented the image according to the number of components ranging from 2 to 11. We then plot the result for the image using random color. For determining the number of components, we use the gradient of BIC score. This criteria gives us the estimation of how our GMM model predicts the data. Next. We visualize the image produced by each option, and we also plot the log of BIC versus number of clusters. We choose the number of clusters that follows an almost constant gradient. In this case, we choose cluster number 10 from this graph. Next. Mean-shift clustering aims to discover blobs in a smooth density of samples. It builds on the concept of kernel density distribution. In the experiment, we use estimate bandwidth from sklearn to predict the bandwidth. Then we use mean-shift from sklearn to perform the segmentation. Next. Next, we get bandwidth 35 from estimate bandwidth. We also tried different bandwidths 15, 20, and 25. We can see that the estimated number of clusters increases when we decrease the bandwidth. Next.
Segsort is a neural network-based unsupervised segmentation method. First, the original image goes through a ResNet to generate features for each pixel. In the meanwhile, we have pseudo-labels, which are generated by an unsupervised edge detector. Then we use seglaws to train the network. During the inference, we can use the k-means to get the objects from the image, and then use k-nearest neighbor and clusters of objects from dataset B to assign the class label to the object. Next, please. Next, please. Here are some examples of predictions. We found that Segsort is very sensitive to pixel values. We think this is because of inaccurate pseudo-labels and semantic information loss during training. Next, please.
The first supervised method for the image segmentation is a UNet, and here is the architecture of the network. Next one. To train on the neural network, this is a table of hyperparameters, and the input is an image and the output of the model is a 3D array where every pixel is a probability of each class. Next one is the training process. Consists of training loss, validation loss, and the overlap accuracy during the training process. The overlap accuracy is defined as the accuracy between every pixel value of the model output image and the label's pixel value. And here are some next one. And here are some sample visualization of the method. Next one. As we can see, the model have good performance in most images, but there are some cases that the model will mistakenly label objects like small objects, dark images. Objects have similar color with background, some object parts, and the images on the right are some case samples. Next one.
The pixel-to-pixel GAN can be divided into two parts, the generative model and the discriminating model. The objective is G star in the equation. The model G tries to minimize this objective against a discriminating model D that tries to maximize it. We trained the pixel-to-pixel GAN model on Google Colab for 200 epochs and get the result. From the result image, we can say it predicts certain parts correctly, but it also generates a lot of noisy pixels. The prediction result is not good. To make comparison, we also trained the model on the cityscapes dataset. We can see from the result that the predicted segmentation is much better than the result on Pascal dataset. The reason is that the image in cityscapes is well labeled, but for the Pascal dataset, only a small portion of pixels are labeled, and the other area are black, so much less information provided. So we need much more input training image and better labeling to improve the performance. In this project, we have implemented 7 machine learning methods to solve the image segmentation problem. To conclude, supervised methods are more reliable when large amount of data is available. Moreover, neural network-based unsupervised method can still achieve reasonable performance without labels. That's all for this presentation. Thank you.